No idea. So we're asked to find x in total area.
No, oh, it's just for this one. Yeah.
Yep.
Yeah.
So we're going to chop off our rectangle here, make our triangles out. Cut this triangle in half. So pull that out here where we can look at it. What do we know about that triangle?
The hypotenuse and the opposite.
Okay, so the hypotenuse is how long here?
Well,
30. 30, right? And the adjacent side is half of the 28. So that's 14. I did forget to label that. This is 28 here. So we need to find this angle, and we need to find the length of this side. To find the length of the side is just going to be the square root of 30 squared minus 14 squared. Which gives us 26.533. The angle is going to be a sine here. We have the opposite hypotenuse sides. So it's going to be the sine of that missing angle equals 14 over 30. So the angle is going to equal the inverse sine of 14 over 30. $27.82 degrees. Now what I really want to do is I want to double that. 55.64. And then, of course, I'm going to subtract that from 360, which makes this over here 304.36 degrees. Because that's really the angle that I want, is that big one. So this dimension here is the 26.533. Of course, this dimension here is 30. And now we're over to the other side. We're going to find this dimension. Of course, we know this dimension is 20. You got to find that one. So once again, we're going to cut this in half so we can look at these. Bless you. We're going to look at this triangle here. So this is 20, this is 14. And once again, we are looking for this side and this angle. So for the side, it's just going to be the square root of 20 squared minus 14 squared. Is 14.283. So this here is the 14.283. The angle is opposite over adjacent, or opposite over hypotenuse again, so it's going to be sine. Since we are looking for the angle is going to be the inverse sine of the 14 over 20. Give us 44.23 degrees. Now again, we want double that. We want the whole thing here. So times 2, 88.85, which means this angle out here, which is the one we really want, is 271.15 degrees. So now we know x. We just add up those 5 measurements, we have x. Comes out to be what?
170.81.
That looks about right, 170.8. Area, we just have 5 pieces to find. Piece number 1 there is 28 by 80, that rectangle. Piece 2 will be this one. That's a triangle. That is 28 by 26.533 divided by 2. Piece 3 will be this triangle. It's 28 by 14.283 divided by 2. Piece 4 will be this sector of a circle, which will be pi times 30 squared times 304.36 over 360. And finally, piece 5 will be that sector of a circle, which will be pi times 20 squared times 271.15 over 360. That total area should come out to be 6,148.35 millimeters squared. If you're within like 3 or 4 millimeters squared of that, you'd be okay.
What was it?
6,148.35 millimeters squared. So if you're within, let's say, 6,140 to 6,156, somewhere in there. Any questions? Okay, so you have the quiz in front of you, and I am going to give you time to work on that quiz in a little bit here. But I want to go over a couple little topics here to set us up for tomorrow. First topic I want to cover is this. If I have a segment of a circle and I know,
What are we calling this? Is this still complex trig?
yep, this is still a complex trig, yes. Let's say I know that the width across the straight edge of the segment here is 80 millimeters. And I know the height here is 16 millimeters. I want to find the radius of the circle that this segment came from. So that means, is imagine a full circle here. What would the radius have to be? This is something we learned last fall, and we learned it again when we're talking about circles. What we really have here is intersecting chords. I'm going to take this 16 millimeter height here, and I'm going to draw it through like this. Now that height had to be measured, and where is the peak height or the maximum height of that segment going to be? It's going to be at the center of this piece here, right? So this piece is going to get divided in two. Does that make sense? So that's 40 and 40. But since this is going to go through the center of the circle here, that makes that a radius or a diameter of the circle. And if a radius of the circle cuts a chord in half, it must intersect it at a right angle, correct? Does that make sense? So we know that's hitting it at a right angle. This piece X here, if you recall, when we were talking about chords before, we'll do just a little sketch over here with another example in it. Let's say that this one was cut into pieces of 3 and 12. If this piece was 4, this piece had to be what? Had to be 9. Because the two pieces of the chords had to multiply up to the same number. 3 times 12 is 36. 4 times 9 is 36. So the two chords cut themselves into pieces such that the product of those pieces is the same for each chord. So what that means up here, since I have two chords intersecting, this chord is cut into pieces of 40 and 40. So that's 40 times 40. This chord is cut into pieces of 16 and X. So I'm going to pause there. Questions on where that formula just came from?
So even though that chord is only 80 millimeters, that equation just is...
Yep. That 80 is cut in half.
So that's 1600 is 1600 millimeters.
No, it's actually 1600 square millimeters. Yeah, 40 times 40 is 1600. The units there would be millimeters squared. Remember, this is 16 millimeters times X. When I divide out that 16 millimeters, the millimeters and millimeters squared divide to make millimeters. 1600 divided by 16 is 100. So X is 100 millimeters, what that comes out to be. So what that means up here is the diameter of this circle is how much? 100 plus 16 is their diameter. So then the radius is half of that, 58 millimeters. Does that look familiar at all now? Should be a little bit, hopefully. So if I give you that this chord is 120 millimeters, and this is 15 millimeters. Find the radius of that circle for me. So we extend this down here. We're looking for x. We divide this in half. So it's 60 and 60. So our equation is 60 times 60 equals 15 times x. 60 times 60 is 3,600. Divided by 15 is 240 equals x. So that means the diameter is 255. 240 plus 15. So my radius is... Any questions on that? Okay. Well, with what we know now, the next step's a lot easier than what it was before. Pretend that looks like a circle. So let's say we've got a segment here that's 40 millimeters wide and we'll call it 25 millimeters tall. How do we find the area of that segment? Well, first thing we need to do is we need to be able to find the radius of that circle, just like we did. So we'll extend this down. That's going to be x. This is going to be 20 and 20. So to find our x, 20 times 20 equals 25 times x. 20 times 20 is 400. Equals 25x. Divide by 25. We get, what, 16 equals x. Does that look right? Anybody tell me what's off in this picture? Well, it's not drawn to scale, obviously. But if that's 25 and this is 16, that means this segment looks like this. This is the 40, here's the 25, and here's the 16, right? Finding the area, that's probably not going to work real well for us. We could find the area of it. Let's do it, just for the heck of it. So that's the area we're looking for. What this is going to turn into is really finding the area of this part and subtracting it from the whole circle. So what we have here is we have a diameter of 41 millimeters. So our radius is 20.5 millimeters. So what that's telling us you got 20.5 here, 20.5 there. We need to know this angle across here. We have to know that angle so we can find the area of the sector here. Well, to find that angle, I am going to cut this triangle in half. I'm going to use this one. So I'll pull that out here so I can look at it. What do I know about that triangle? Well, I know it's a right triangle. I know that this side here is 20.5. That's just the radius of my circle. I know this down here is 20. That's half of the 40 down here. So then this angle up here is what I'm looking for. This is the hypotenuse. This is the opposite side, which means I'm dealing with a sine. Opposite hypotenuse make the sine. So my angle is going to be the inverse sine of 20 over 20.5. Which means it's going to be really close to 90. $77.32 degrees. So that 77.32 degrees is half that angle, so I'm going to find the whole thing by multiplying by 2. 154.64 degrees. Now that I have that, we can go about finding the area of that green piece. We're going to find the area of the circle is pi times 20.5 squared. $1319.59 millimeters squared. Then we're going to find the area of that sector, which is the area of the whole circle, 1319.59, times that angle of 154.64 over 360. $566.84. So that's the area of that whole sector. Now we need to subtract off the area of this triangle here. Well, the area of that triangle, to find it, I'm going to need to know that side. That side is going to be the square root of 20.5 squared minus the 20 squared. So 4.5 is all that side is. So the area of that triangle is going to be 40 times 4.5 divided by 2. Which is going to be, what, 90? Millimeters squared. So the area of that segment out here is this area minus this area. So 476.84 millimeters squared. So that's the area of the green segment. I wanted the area of the yellow segment. So that's going to be the whole circle. 1319.59 minus the green segment. So we got 5. 842.75 millimeters squared.
The area of the sector minus the area of the triangle. Subtract it out from the whole area of the sector.
It was the area of the whole sector. We do it in black. Area of this whole sector minus the area of the triangle gave us the area of the green segment.
Yeah.
But in this case, we wanted the yellow part, the rest of it. So once we found the area of that green segment, we subtracted from the area of the whole circle to get the yellow part. Tomorrow we'll look at, if I give you better dimensions, so what we are looking for is that segment. Because what we're going to be working on tomorrow is we're working on something like this. If I have a block and I am milling a channel out of it that is a segment of a circle, find the volume, and then using the density, we're going to find what is the mass of that block after we've milled out that channel. So that's where we're heading with all this. For now, you've got that quiz to work on. I'm going to give you the last 20 minutes to work on that quiz. And that quiz is all that is due for tomorrow.